Hi, I'm Kyle Christ. I am in Fundamentals of Physics, Section 1 at Full Sail University, July 2010, and my instructor is Professor Stewart, and I'm going to show you today the floating needle experiment. This will demonstrate surface tension of liquids, specifically water in this experiment, and we're going to show you the strength of tension force. Even though it is generally weak, as we all know, it's easy to break water or the surface of a liquid when we stick our hands in it or something. It's generally very easy. A liquid, if an object is more dense, the object will sink in a liquid if the object is more dense than the liquid. If it is lighter, it will float. Here we're going to use a measuring cup of water and a sewing needle, and we have a pitcher of water. Now this needle is more dense than ordinary tap water, but due to surface tension force, I will show you a way in which we can get this needle to sit on the surface of the water without sinking. Surface tension is created by a liquid that is in contact with a gas, such as air. By pouring this liquid into this container, and we're going to fill it to the top so we have as much surface area to work with. There you go. Fill it to the top. Now, what we're going to do here is we're going to take a square of toilet paper that is just big enough to cover the area of the needle. And we're going to make sure the needle is dry so we don't get our toilet paper wet. Now what this is going to do is we're going to put the needle on the toilet paper, and I'm going to crease it just so it holds up a little bit better and I can hold it by the toilet paper instead of by the needle. And what this is going to do is it is going to hold the needle horizontal so we can spread the surface area over as evenly as we can over the water with as least amount of contact. The toilet paper will soak up the water in the measuring cup, and after about 30 seconds we will see the toilet paper fall to the bottom, and we should see the needle floating. So we're going to put this in very carefully. Now, if you watch carefully, the needle is floating. We have to fix the, there we go. Oh, the toilet paper is stuck on the rim here, but as you can see, it has left the toilet paper and is now floating away by itself. So what we learned here is that the surface tension of water, even though it is very weak and the experiment is very easy to mess up, the surface tension is actually strong enough to hold certain objects above water, even though they are more dense and should normally sink to the bottom. I would like to thank about.com for this physics experiment, and yes, I hope I showed you that the gravity force pushing down on the needle is weaker than the surface tension that is holding up the needle. It is still floating and should constantly float. Thank you.